Hello and welcome to my channel. Today we're going to be doing a quick mini lesson on C versus Python, where we're going to go all the way from understanding the basic syntax structure to the key components that you'll be using to build your programs and applications. Now before I begin, I do want to go over my motivation and my target audience because I do think that will be helpful context for the video that is coming. So if you are trying to skip directly into the lessons, timestamps will be provided in the description below. So this may come as a shock to some of you, but I am not a FANG engineer. I'm actually a finance analyst. And while I'm currently doing a master's in data science, I did begin my programming journey self-taught throughout undergrad. And one of the biggest misconceptions that I think I had faced, and I think a lot of my other finance colleagues and other less technical people had noticed, was this misnomer of the difficulty in coding. And believe me, we've all been there. Programming and computer science in general gets a very bad rep due to overly complicated syntax and new technological advancements. It seems like every single day. But the concepts and principle are usually simple, fairly digestible, and usually straightforward to implement. And this is typically why you hear people recommend learning Python to start, because Python has very simple syntax, it's user friendly, and for all those reasons they usually say to avoid learning C. My main goal for this video is to demystify the difficulty in learning C or Python or any programming language for that matter, and really try to put the power in the individual that's watching this video. So hopefully at the end of this video you're going to get a really good understanding of what Python is if you didn't know it already, how this also translates to C, and then hopefully a better general understanding of programming languages and computers in general. So my secondary goal for this video is really to provide people like me, either self-taught programmers or people that have this misconception of the difficulty of programming, a resource to learn Python and C in tandem, because I do believe there is a gap in YouTube educational content on bridging the gap between languages and languages, and I think we do a lot of sticking with Python, and it might be a time to go into a little bit of lower level given the recent advancements in GPUs and processors. For that reason, I would like to give you a straight shot in learning Python and C in tandem to get you started with using a lower level and maybe a higher level language today. Now that we got the motivation out of the way, I want to be very clear about who this video is targeted for. And the first group of people that this video is targeted for is users that have a basic coding experience. So this can be anything from just understanding what an IDE is, how to download and program software, or programming languages onto your computer, or so forth. Let me be clear, this should not be your first time ever coding or trying to program anything. There's other YouTube videos out for that. And this should be, you have a base level knowledge, or you believe that you are relatively smart, that you'll be able to pick this up pretty quickly. The second group of users that this is going to be aimed at are Python users looking to transition to a lower level language. So trying to give you a little bit of exposure into going from Python, which is a higher level general purpose language, to C, which is a procedural language. We're not going to have the debate whether C is a low level language or not. It is lower than Python, and I'd like to give you a straight shot into exploring that option. The third option is going to be what I like to call hyper learners, and there are people that are looking for the foundational knowledge as soon as possible so that they can get straight into tinkering. These people like to learn extremely fast in short bursts, and go off on their own to build whatever, and they just like to have the foundational knowledge to understand what is happening, and they can go off and learn and research the rest. So that's going to be the third group that this video is going to be targeted at. So now that we've covered our basic motivation for creating this video and our target audience, I think we're ready to get started with our lesson. So with that, let's get going. So welcome to the first lesson in learning C and Python side by side. Like any good programmer, we are going to be doing the Hello World program so that you can write Hello World in both C and Python. As a quick note, this tutorial does assume that you have GCC compiled and installed on your Windows operating system, and these small tweaks would need to be done for Linux and Mac. And you could just go look it up or find ChatGPT to go look it up. We'll be using these magic cell commands. If you don't have GCC compiled and installed, um, this is what I used essentially to install it. Um, I would follow this CodeBear video. It seems like he posted a couple updates, and this one came out November 25th, so only about a month ago. So still very relevant, and it worked for me. But without further ado, let's get into the lesson. So starting off with, just saying hello world in C. Like I said, there's going to be these small tweaks depending on your operating system, so please make those tweaks. But we're going to be using these magic commands, these magic cell commands that do these double percent signs. And this is essentially going to write a file, so using double percent sign, file, and then the word, hello world.c. This will essentially create a file given this cell, and it'll allow me to type whatever I need. So just starting off with the basic syntax of any C program, usually at the top you're going to see these two libraries, these header files, your standard input output and your standard library. Don't worry about so much what they are or what is in them currently, but just know that a lot of your functions, a lot of your basic input output functions are going to be within these two header files. So I would recommend just including them at the start of most C programs, if not all. So the basic C syntax is going to be C does need to know does need to specify a return type. So in this example, we can see we're defining a main function that returns an integer. So we have int main open and close parentheses, and we have our curly brackets. Underneath, we're going to have our return type. So if this was a character or an array, this would be changed. But right now, we're just going to be sticking with int. So return 0 if this code is going to run successfully, and 1 if it doesn't. And what this block of code is going to be doing is just going to be printing hello world on a new line. We're going to be using the printf function to print hello world. And please note that at the end of every line in C, or I would like to say every command in C, you would like to put this semicolon, this number right here. So just hitting run here, this is essentially going to write this file. I actually already have it here in intro, but just to run the file, it's going to write the file here, and we can actually open it up to see hello world.c. And this is really what your C programs are going to look like, since I am doing it in Jupyter Notebooks. Shoot me, doesn't matter. I'm just doing it just because it's the easiest way to show the difference between the two languages. But this is essentially what your C program would look like if you were going to type in a .c file and not a Jupyter Notebook, which is definitely not advised, but I think it's warranted just for the tutorial. So essentially, this will write this file, hello world.c, and then we can use our magic commands again to compile. So this is essentially what you would put inside your terminal window, inside your terminal if you were going to compile it inside your .c program. So command gcc hello world.c .g.o hello world.exe, create an executable file called hello world. So here, let's compile this. All right, we got a success, and from here we can just do our magic command and run the file, and we can see we get hello world. So very simple. Very simple. C is not too bad, the structure of the programs, and it won't be too bad. And this is essentially going to be the format that we're going to be running at for the rest of the lesson. And obviously saying hello world in Python is very simple. Just using Jupyter Notebooks, you can just use the print function and just write hello world, and that'll print out hello world to our console. And that is going to be the first part of our intro to Hello World, C, and Python. So welcome again. We're going to be going over data types in Python and also in C. And for the remainder of this tutorial, we will be sticking with Python first. We'll be showing examples in Python, and then be covering the examples subsequently in C, just because Python syntax is a little bit easier to understand. So apologies if this is a little bit of a review or a refresher for some of you guys. Hopefully it's still going to be important. But in Python, we're just going to start off with strings. We can declare variables using the equal sign, and strings can be enclosed whether in single or double quotes. We also have string addition, so we could do first name plus last name, and we could print the first name plus last name like this. As you can see, uh, the full name, where we concat first name and last name, does not include a space. So what we can do is add a space here, and you can see the full name is Cannon Johnson, which is my name with the space. But this is just an example of using double quotes as a space. So getting into numbers, so we could obviously do integers as whole numbers or floating point numbers, which represent decimals, and also some basic arithmetic. So you can see with these print statements, print age after 5 years, we do my age, which is 23 plus 5, I'll be 28. And then age after age plus years to the future, so 28 years, and there's 5 years to the future. So if I run this code, you see age after 5 years is 28. And this is just another example where you can see where we can where you can start to see the structure of Python in formatting print statements, where you can see we can have a string, some part of text, a little bit of an arithmetic operation or whatever variable reference, another string, and another reference to another variable. But that's how essentially you do this in Python. And here just going to be basic arithmetic operations: plus, minus, multiply, divide, floor, modulo, exponential. And here you can just see just a basic overview of how those form. I'm not going to go too much into this because I'm going to assume that you guys understand basic mathematics and arithmetics, but that's how all of these work, and you can kind of look it up. One thing that's important to mention about Python is that Python has an additional data type called Boolean. Most of the data types are going to not be Boolean in C. But here you can see if I just put A is equal to true or false and I print the type, it's going to be type Boolean, which just goes back to true or false. How we would do this in C, since C does not have Boolean, would just be 0 or a 1. But Python does support Boolean data type. So just something that something to know, something to look out for. So jumping down to data types in C. So since C is a little bit more declarative, it requires something called a format specifier when you're going to be using your printf function. And here's just like a quick table that I wrote up. Here you can see %d is going to be used as your integer, %s is your string, %c is your character, which would be like a single character, f is your floating point or double, and %p would be using printing your pointer address. So here's going to be our block of code here that we're going to be replicating. So I'm just going to actually jump into datatypes.c that we have already created, just so it's easier to see and I think a little bit more familiar for the C syntax. So we're going to be including the standard input-output header and our string header. We're going to be using our main function where our return type is going to be an integer. So at the bottom of our function, we should have a return 0, assuming that our function is successful. But you can see defining data using C is very simple. So strings are actually going to be in double quotes. We can't do single or double quotes. It's just double quotes. You see character, first name, and then we're going to be using our square brackets. Our square brackets to define our string value. So you can see char, last name, square bracket, Johnson. And this is essentially just going to say like the amount of space that our full name variable, which is a character type, can hold. It's hold 50. We're going to get a little bit more into memory towards the end, but right now just understand that this number would have to be big enough to hold both Cannon and Johnson for a first full name. So I think 50 is a pretty good number for that. So here you can see now we have numbers, integers. So int age is equal to 20. Double years of experience is equal to 1.9, which also are decimal or floating point values. String addition in C, so we can't necessarily do the way that we do addition in Python using just the plus minus. We have to use string copy. So just an example that you use the string copy function, and we could copy our first name into full name, concatenate a space. So like we had to do with Python, adding a space, we still have to add the space, and then we're going to also add back on our last name to full name. And here we can just see we can print out first full name, percent sign S, which stands for our string or floats, and I can print out comma full name. And first name should be referencing here. Backslash n is just going to be your new line character. C is not as smart as Python, and you're going to have to include a backslash n, which is a little bit annoying when you first get into it, but you'll understand why later. But here you can see we're doing the same thing. So the full name is going to be percent %s, and he is percent %d years old. So this would refer to our character and then also our age. So C, this is again our basic arithmetic like review. I'm not going to go too much in depth in this. We have an integer value of A and B, and then we're going to be doing addition, subtraction, division, division with an explicit float, explicitly casting to a double for floating point division. This is just like a very small nuance in the C language that I'm gonna demonstrate just using the division. Modulos, which would be the remainder after the division, and these are some more math functions that you might need to know. So if you want to take the power of something, you can use the POW function. The ceiling of something, say it's 9.8, ceiling 10, floor 9, okay? Very simple, square roots, we all get this. So in C, one of the most powerful data structures that we can use would be a struct. And structs allow us to store different types of data within a single data structure, which is really helpful for us. Say we have like a large data set and we have, different types of, strings, doubles, integer values, anything. We can store that all within a struct and access the struct through this keyword, which would be person. So typing typedef struct, and then we can add a name and an integer value, and then this would be the code name at the end would be person. So this is essentially how we define our struct and our data structure that we would want to store our data in. And you can see right here, you just access person, and I could just say P1 to create a P1, an instance of P1 within the struct. And here I can just add P1 age is equal to 23, and I can copy the name. This is just a little bit interesting. You can't necessarily do this with P1. You cannot necessarily do P1 dot name is equal to canon. That doesn't work in C. You're going to need to use the string copy function to be doing to be inputting data within our typedef struct. So here you can see that line here, and then you can see the name of our P1 in our struct is %s, and we're going to be accessing this P1 name, which should be canon, and the age in our P1, the age of P1 in our struct is %d, and we should be accessing 23 again. So flipping back over to the Jupyter Notebooks, I'm just going to hit run here, and this should create the file. It's already created, but it will create the file, and we're going to compile it using our GCC compiler, and then we're going to be running data types. And here you can see, first name, first full name, and he is 23 years old. Here's the result of our addition and our arithmetic operations. And then within our struct, you can see this is how our data can be inputted and later accessed. So jumping over to arrays in Python and in C. So here we can see we define our grades variable is a list, and it's 80, 90, and 100 are our 3 grades. Very simple, average of 90. We can see that we can access any of our grades via indexing by putting a square bracket at the end of our variable and accessing the index value. So Python actually does zero-based indexing, if you didn't know. So this was going to be element 0, element 1, and element 2. So accessing the first grade in the list would be 0. So you see if I run this line, the first grade in the list is 80. Okay, and we can do the same thing again with strings. So first student in the list is canon. Okay. Python also does have a little bit of superpower, I would say, with slicing. So you can see we can slice from, it's, the syntax would be from to. So if I did like, sorry. So if I did std names from to is essentially our syntax for Python list slicing. So you can see we're going to be taking our first index number all the way to the end of the list. So the rest of the students are you know, John and Sally, and the last student's name is Sally. And we can do this in Python. They have a very simple way of accessing the last element of the list, which would be -1. You don't have to find the length or anything like that, just use -1, and this points to the last element of the list. But say it is important to know the length of arrays or list. Python does have a way to do that very simply. Just use the len function, and you can see our length is 3, because we have 3 students and 3 grades. Okay. So jumping into arrays in C, again, I'm going to go into our arrays.c file before running the code, just to do a quick code walkthrough. So again, we have ints, our return type is an integer. Again, don't forget this piece. And here you can see we're going to initialize our grades variable just like this. The easiest way to initialize an array in C is going to be using those weird brackets, these curly brackets. But we're going to have the same access to list slicing as in Python. So you can see grade 0 is going to refer to the first grade in the list, because it's also 0-based index. And I could also change this grade. So let's say if I wanted to change what the first grade is, I can do grade 0 is equal to 85, and now the first grade should be 85 whenever this second line prints out. And this is just, I kept this piece in not because it was important, but just to understand, just to show that C executes stuff line by line by line. So just to kind of show the execution pattern of how C is running its programs. So then we have something like new student Mike. So this would be 5 bytes. So again, I don't necessarily have to put this 5 in, but that is explicitly what C is doing. It's allocating a byte for each character. So 1, 2, 3, 4, and 1 for the end of sentence, which would be Mike. So then here you can see I'm printing out the size of the name. So the name and then the size of the name, and I can use this function size of to determine the bytes. And this should be printing on 5 bytes. And the number of bits is going to be 8 times by the number of bytes. It should be 40. Okay. So string arrays are a little bit different. We're going to be using this character, and we're going to talk a little bit more about what this character is, this pointer character. But for now, just bear with me. We're going to get to it. But you can see the basic structure of defining any array, pretty similar to the curly brackets and our quotation marks. Our first student is Canon, should be. And finding the length of arrays in C, we don't necessarily have our len function. Our len array is equal to this, right? We don't have that in C. What we have to understand is the total size of the array divided by the size of one element, and this is all going to be in bytes. If this is a little bit confusing for you, don't worry. It's a little bit confusing for me even now, currently. But this is essentially how we're going to be finding the array of integer arrays in C. So size of grades divided by the size of the first grade, so of one element. So just flipping back over to arrays, let's use our magic command to make file array.c. Let's run this. Okay, overwriting. We're going to compile this code. So success, there's no errors. And now we're going to be able to run the code. So you can see we have the first grade is 80, which is perfect. That's exactly what we had in Python. In C, you can see that we actually changed the grade to 85, so that's correct. The size of the name, Mike, is 5 bytes, so 40 bits. It makes sense. The first student in the array is Canon. The number of total grades in the array is 3, so this would be our length. using our, flip back right here, of using our function right here. Okay. And the last grade in the array is 100. Yeah, I don't think I mentioned this. So with Python, obviously you can use the pointer of -1 to point to the last object. With C, you're going to have to know the length of your array and then just subtract by 1 because of zero-base indexing, and that'll get you your final element of the array. But that's going to be your walkthrough for your basic data types and arrays in both C and Python. So now we're going to be going into conditional statements and a little bit more of a dynamic programming approach using Python and then later in C. So just starting off, like I mentioned in the data types section, Python evaluates all conditions under Boolean logic. So you can see if we have a number that's equal to 42. If the number is equal to 42, this will evaluate to being true. This will evaluate to being false. And then we also have the not operator. So if this is true, now this is not. Okay, very simple. And you could say true, false, false. Okay, very simple. So a lot of times in our programs, we have a condition that we would like to execute if something is true and something else if something is not true. So for example, let's say we have A is equal to 5 and B is equal to 2. If A is bigger than 5, so as 5 is bigger than 2, print A is larger than 5. So very simple. You can see the syntax. We have our if, we have our wrapping statement, and then we specify, we start our if block with this semicolon. Now if we set B to be larger, right, so now A is 5 and B is 10, we would need to have an else statement. So we have these conditional words, if, else, elif, that we can use in Python to control the direction of our program. So let's print this out. We can see if A is larger than B, print A is larger than B. If not, B is going to be larger than A, and you can see that it's true. Here you can see kind of the same thing except with an elif statement. So let's say we set A and B both equal to 5. A is greater than B, we'll see A is larger than B. If not, this elif statement is essentially going to check. If not, check this. If A is equal to B, equivalent to B, A and B are equal. If not, B is larger than A. So we can run this, right, and see A and B are equal, or we can change this to 7 and run it again. A is larger than B, and change A to under 4. And now you can see kind of how our program flows. It evaluates these statements as true or false. So here you can see a combination of if, like with multiple conditions, using the AND operator. Now this could be either AND or, but you can see in this example, I see now, and or. So name is Cannon, age is 23. If our name is Cannon and our age is 23, we'll print out my name is Cannon and you are also 23 years old. Now, if I change the name to John and I keep the age the same, I say if my name is Cannon or I am 23, you say your name is Cannon or you are 23 years old. So you can see we print this out, and this will still evaluate as true because one of these conditions is true, as in 23. So jumping into conditional statements in C, let's just open up conditionals.c. That way we can just see it in a more C fashion. So we have our standard, function syntax, and we're going to be doing the same thing. If A is equal to B, or if A is greater than B, we're going to print if A is larger than B. Again, we're going to be using the \n here just because we're going to be printing out multiple print statements, and if not, they will come on the same line. So if A is greater than B, print A is larger than B. Now you can have default values. This, I guess, else would be considered your default value. If this is true, do this. If not, default to this. So if A is greater than B, print A is larger than B. Else, print B is larger than A. Now, the most flexible approach, which would be the way that we had replicated in Python using if, elif, and else. Uh, C does not actually have the elif operator, or it doesn't have that command. We have to use something called else if, which is obviously the same thing. So we're just going to be building that same program. So we're going to set A is equal to 4 and B is equal to 4. We're going to overwrite those variables, which is why we don't have to declare them as an integer. But you can see the flow of the program. If A is larger than B, we're going to be printing A is larger than B. Else, if A is equal to B, A and B are equal, else print B is larger than A. And in this example, we're going to be printing out A and B are equal, obviously. Here you can see we're defining, again, our string canon, and our age is 23. So here's just a couple comments on what those logical operators are. So and is going to be your double and signed, and or is going to be your, I guess, these two straight lines. In Python, obviously, it was just and or. It's a lot simpler. Equality is the same, but the inverse, there is no not. There's no not, like not x is equal to 42. In our last example, that's not a thing. We can just use our exclamation point. Excuse me. So evaluating with two or more conditions, same as we did with Python. If name is canon and your age is 23, we're going to print out your name is canon and you're also 23. Now this is the or, so if your name is John or you're 23, your name is canon or you're 23. So it's kind of like a guesser. And here you can see the logical operator is not. So if name is not equal to John, the name defined, and this is going to be printing out the name that we had already defined here, which is going to be canon, is not John. Okay, so very, very simple like logic that we can use to build our program. So just going back to run it, so we're going to run the makefile, compile with GCC, no errors, and run our program, and we're going to be getting our expected results. So A is larger than B, A is larger than B, A and B are equal when we set them both to 4. Your name is canon. This is when we were evaluating multiple condition, and then here you can see the name defined canon is not John, using the not operator in C. So often as a subset of dynamic programming, we're going to be wanting to loop or iterate over arrays to do whatever with our programs. And Python lets us do this in two very simple ways. We have our for loops, and then we have our while loops. So starting off with number 1, our for loops, you see we define our variable myList is equal to 1, 2, 3, and we can directly iterate over this list just by using this for loop. So for I in the list, print I. This will print out every single element in the list. Let me actually clear these outputs just so we could run it together, and you can see 1, 2, 3. Now, while this isn't necessarily best practice, sometimes you are going to want to do this. More often than not, you're going to want to know the iterator or the index, and also have the element. And for the Python users out there that are watching this, please bear with me. This will probably be a review, but I would say the most common way to get the index and also the array element would be using range and len. So len just figures out the length of the list, which would be 3, and range returns an iterator between those two, from 0 or whatever thing you specify, 1 comma. But range will do start to stop, exclusive of the stop. So it will return an iterator, in this case of 0, 1, and 2. So just running this code, this is going to print the index position and the array element. So great, beautiful. You can see index position is 0, array element is 1, index position is 1, array element is 2, index position is 2, array element is 3. So everything is working properly here. So jumping over to while loops is going to do something indefinitely until this condition here, index is less than 3, until this proves to be false. So it's very simple. Definitely look out for infinite while loops. They are real, but don't worry, they can't hurt you. And they're pretty simple to fix. And hopefully that doesn't happen in this example. But the syntax here is while index is less than 3, we're going to be printing out the array index and the array element. And here we just have this nice clean Pythonic syntax to increment idx by 1. So if I run this, we're going to have identical results. So for and while loop. And this is just another way that you can do it. We can show you this by decreasing. So while something is true, just decreasing the index. So this is going to be that answer in reverse. So index position is 2, array element is 3. Index position is 1, array element is 2. Index position is 0, array element is 1. So very simple how we can use for and while loops, given a stopping condition to do X, Y, Z within our programs. So jumping over to loops in C, let me just open up our loops.c file so that way it's in a way that is a little bit more legible. And we're going to define our list exactly the same way. So my list is 1, 2, 3. And the syntax for loops in C is a little bit more complicated, so I'm going to take a little bit more time to go over it. You're going to have to wrap your for loop within these brackets. So for I is equal to 0, this is going to be your starting position. So int I is equal to 0. You're going to be using these semicolons, and this is going to be your stopping condition for when I is less than 3. And this is just saying that we're going to be iterating I positively. So iterate I by 1. So pretty simple. It's a little bit more wordy, but I think it's still pretty legible when compared directly to Python. But you can see the index position is %d, which would be I, and then our array element would be the same way that we're going to be slicing or indexing our list in Python is the same way we do it in C. So jumping over to while loops, again, very, very similar of what we just learned or what we just talked about in Python versus C. Infinite while loops, definitely look out for them. They're not real, don't worry, they won't hurt you. So while I is less than 3, and in this case I is 0, we're going to be printing out our index position and our array position, and then we're going to index I, increment I by 1, and this will obviously turn false at 2. So this should get us all of our all of the elements out of our list. But what happens in the scenario that you don't necessarily know the length of the array? What are you going to do then? So we're going to combine what we learned from the last lesson on how to figure out the length of an array of a list and use that as our iterator, or use that as a piece for our stopping point. So I'm just going to be finding out the length of my list and storing that within our variable n, and I'm just going to print that out. Printf, the length of the array is %d, and we're going to be accessing this value n here. And from here, we're just going to be using a for loop to kind of show how we can do this. So for int I is equal to n minus 1. So this is going to be the last element of the list because this is 3 minus 1. And we're going to be stopping. Our stopping condition is when I is going to be either greater than or equal to 0. And we're going to decrease I. And every single time, we're just going to be printing out that number in the list. So just going from the last element to the first element of the list, we're just printing it out. So very simple. Let's go back to our Jupyter Notebook and let's run this. Let's run loops.c. Let's compile and run, and you see what we get. In the example of the last, where we dynamically find the length of the array, you can see that the length of the array is 3, and we're successfully able to print out in decreasing order all elements of the list. And with the groundwork of dynamic programming laid, now we can finally get into functions where we can kind of wrap some of that functionality into some type of repeatable process or something that we can call. So starting with functions in Python, very simple to define them, as you see with most of Python syntax. We're going to define def, and here's going to be our function name, and anything with inside these parentheses is going to be a parameter. In this case, we're just going to be passing name, and again, these your colon is going to be used to start your function. And only thing that this function is going to be doing is printing hi, comma, that name that we pass in the function. So let's just define the function here. Boom. So the function is defined, and here we can call it, and we could call it using anything. So just because we're probably going to be posting this on YouTube, so say hi YouTube, and we're on Microsoft Visual Studio Code. Let's say hi to Microsoft. So hi YouTube and hi Microsoft. So these functions are really simple in Python. Here's a classic example of FizzBuzz, or like a foo bar example. If A is bigger than B, we're going to print fizz. If they're equal, we're going to print FizzBuzz. And if not, so if B is bigger than A, we're going to be printing out buzz. So let's just define the function, and now we can call it a couple different times. So this should be fizz, buzz, and FizzBuzz, because they're equal. So very, very simple how we do this in Python. So flipping over to how do we do it in C, once again I'll open up functions.c, even though it's very small. Just take a look at it. One thing that is really important in C, functions in C are very interesting, and they need to be defined before you use them, as C is going to need to understand a certain amount of information prior to when the function is called. So the way that I like to do this in C would just be at the top of the function, or at the top of your file, is to list out all the function that you're going to be using. But there's other ways you can do this. You can do this in importing header files and whatnot. But for the purpose of this tutorial, we'll be doing it this way and just defining our functions at the top. So we can see void is essentially another return type, which essentially doesn't return anything. And we're just going to void say hi, and we're going to be taking a character name as a string. So if you remember, this is how we define strings in C. And we're just going to be printing out hi, that name. So exact same that we just did with Python. Similarly with FizzBuzz, FizzBuzz doesn't return any number, it just prints. So void FizzBuzz, and it's going to take two parameters. It's going to take integer in A and integer B. And it's going to say if A is bigger than B, we're going to be printing out fizz. If they're equivalent, FizzBuzz. And if B is bigger than A, we'll be printing out buzz. So very, very simple. And within our int main function, where we have our return 0 for that matches our return type, you can see where we call the function. So we could call say hi with YouTube and Microsoft the same way that we did with Python. And we can call FizzBuzz the exact same way. FizzBuzz 5.1, 2.5, and 10.10. So let's just jump back over here. Let's overwrite this function. Let's compile. So we have no issues. And we're going to print. So there you can see your hi YouTube, your hi Microsoft, FizzBuzz, and FizzBuzz. But the purpose of this is kind of just to show you that you can modulize your code and kind of wrap some of the stuff that we've learned into functions, and you can call the functions to do various things within your program, and this is how you would do them. So now it's time to work with files directly within our program using Python and also C. And there's loads of different ways that you can bring files into your programs. I'm just going to be demonstrating just two ways with Python and one way in C that I learned that I think are very easy. Directly from the CSV package, or before I start actually, the data set that we're going to be going over is going to be the IRIS data set, which is very popular machine learning data set on classifying, I think, flower type, Setosa. Not that any of this matters, it's just the data set that we're going to be using. It's hopefully familiar to some of you, and if it's not familiar to some of you now, it will be familiar to you later. So back into this. This is directly from the CSV package documentation. This is how they recommend working with CSV files using with open, importing your path to your file. So I just use my path here. My new line is going to be this, like, space as a CSV file, and you're going to be using your reader to print each row. So running that line of code, you can see every row of data. So this is our header file, our header, our columns, and this would be our data. Now, I don't think that this is very useful. More often, it's useful to put it into a data frame, like maybe like an Excel file, like something like that emulates that. We can do that using Pandas, very popular Python package. Sure, most of you guys know it already, but we can just import Pandas as PD and use the Pandas function read CSV to store it in the data variable, and then we can just call the data function or data variable. While this runs, you can see this is now in a much more legible manner, where you can see the number of rows, the columns, and whatnot, whatever other information that you need to know. So now that we covered working with files in Python, let's take a look at how we would do this in C. And we can just do it right here because this is all the code that we would need to open files in C. So inside our main function, we're going to be pointing. So this is the first time I'm probably going to be mentioning this, but following the next section of this video, we will be going over memory address, but we are going to point to the file position using fopen and this file path. And we're going to be classifying it with R. R would stand for read, W stand for write. Right now we're doing read because we're just going to be looking at the function. And here we have an if check. So if the file is blank, say there's an error open the file, and we can return 1 rather than returning 0 as a return type. If this doesn't happen, if there is no errors, basically what we're going to do is we're going to create a line character, and this is essentially a buffer to store each line, all the data on each line. And then we're going to be using this while function. So while f gets for line and the size of line each byte, so the byte of the line, we're going to be grabbing every single line from this file, as long as it's not equal null. So while we're grabbing these files, get the file until it is null. And within the while statement, while this is executing, we're just going to be printing out each line. This line will get saved over and print each line. And extremely, extremely important to remember about C, if you choose to open a file, you must also close the file. So if you use fopen, you must use fclose. Okay? So here we're going to execute this. We're going to overwrite files.c. We're going to compile it using GCC. And then we're going to run. And here you can see now our C program, we're going to be able to actually use the data within our iris.csv file. So that is how we access data and files using Python and C. So this part of the video is definitely the most challenging, I would say. Programmers alike, I think pointers are and memory addresses are just a little bit of a tricky subject. But we're going to take it step by step. And I'm also going to be providing additional resources if you're still struggling with the concept. But hopefully you're going to be able to follow along. So just take it step by step. And if you don't understand it the first time, try to rewatch it or go back to the supplementary information. And that should do the trick. But basically, we're just going to have our basic function signature, int main. I think you guys get the point at this point. Where we're going to define our variable age is equal to 23. We've been using these asterisk signs. This essentially means a pointer. So this is going to point to something. And in this case, it's actually going to point to the memory address of age. So one way we can access the memory address of any variable is just using the ampersand sign. So putting ampersand age is going to be the memory address of age. So this line essentially reads int pointer page is equal to the memory address of age. And here you can see that we're going to be printing out the same thing here. This is essentially doing the same thing. So the age's memory address is going to %p, which is a pointer format specifier, and we're going to be using our dereference or our access and memory address using the ampersand sign. And then the line directly under that is going to say print age's memory address, and it's just going to be accessing the pointer, because if you remember, the pointer is storing the memory address already. So these two things are equivalent. Now jumping down, let's say you want to access the value. How we do that is we can dereference any pointer back to the value using the asterisk sign. So we just say print age, age's value is %d, dereference our pointer to age. We'll be accessing the value 23, and that's the same as just doing printf, age's value is %d, and then accessing age directly. So just a quick overview of how you use it, using the percent or the ampersand sign, and then also your asterisks. So, but for illustrative purposes, like let's just see like how you can go back and forth. So you can see like this multi-dereference example where we're printing out the dereference age, so the value, and you can see that we're just going, memory address age, okay? It's very simple. If we wanted to get the memory address again, we can do age, right? Prints dereference memory address. I change that. For the purpose of this, just keep it simple. And nobody would ever do this. But it's just kind of interesting that you can see how you can go back and forth between referencing the memory address and then dereferencing. So one thing that was not clear to me when I first started coding in C was what pointers are used for. Why are they useful? Why do we have them? Why do we use them? And one way that I found, I'm still learning, but one way that I found is that it can be used for copying variables. So you can add your pointer to age and save that into age, which essentially means that you can now mess with your age variable without actually touching your age, your original age. So say like a copy, exactly. So just one simple way that you can make a copy. I haven't seen this too much, but I haven't been coding in C very long. But I did want to throw it in because it is one way that I saw that pointers can be useful. The other way is double pointers. So double pointers essentially point to a pointer. It's a pointer to a pointer. So you can see here we have int, a value is 42, and we're going to be accessing the memory address of value and storing that in our pointer value 1. Sometimes you see these as PTR1. It doesn't matter. This one's PV1. Then we have our memory address of pointer value 1, and we're going to be referencing that in pointer value 2. We're essentially going to be double pointing to this, like point to point, as you can see, and we have a triple pointer pointing to pointer value 2. So here we can just triple dereference it. So after triple dereference, the value is %d, so we're going to access the value, and we're going to dereference, getting us back to our initial value of 42. So if that doesn't make sense, I'm going to pull up some supplementary material that I use to help. So, sorry. So here is something I just found on Google, but you can see this illustrates what a pointer is. You can see that they define, my variable is equal to 7, and you can see that there's a pointer to the memory address. These two things are the same, x2000, x2000, okay? And then obviously an example of a double pointer, you'd have another pointer variable pointing to this address. But that's all pointers is. It's very simple. It's just a type of data that stores memory addresses. And if you're still looking for help on that, I would definitely check out this guy, Low Level. This guy is an absolute beast. I really love his content. And this is what I use to kind of understand, you have a better understanding of what pointers are doing. It's an 8-minute video, so if you're struggling with the concept, either rewatch this video, or I would go to one of these resources, either this one, this guy Low Level's channel, or try to find this pointer image, and that'll help strengthen the connection in your brain. So now let's talk a little bit about void pointers. So say we don't have an integer pointer. Let's say we have a void pointer, which would point to essentially nothing, or any type of data that it is that it could be holding. So in this example, we have a double, which is num, which is pi 3.14, and we're going to initialize a void pointer called v pointer, void pointer. Here we're going to set the void pointer to the memory address of num. So this is now going to be equal to the memory address of num. And whenever we're going to use a void pointer, in C++, this is explicit. We'll need to have this. But just for best practice in general, you're going to want to cast to an integer, the integer type that you're looking to return, and then choose to dereference. So like you can't do you can't do int void, int pointer to a void pointer, and then try to call a double. This will need to be a double, so this will need to match. So, double pointer. This essentially means cast to a double, and then here goes our similar sign again, where we're going to dereference the pointer. So that's all this is doing. So we're going to cast our void pointer to a double, and then we're going to dereference it, and we're going to print the integer. And I haven't talked about this in the course yet, but the .2f just means the amount of data or decimal places that you're going to be showing when you output. For example, just 0.2. If I put this as 0.5, it would show up as 3.14000. I think you saw that a couple times when I've done some prints and integers, but this is the way that you can control the amount of decimal places that are shown using 0.2f. So with that, let's run this. So because this is actually just a C file, we're going to use the terminal just to cast. And I actually already have those commands saved, so we're just use dcc-o pointer and compile, and then /pointer to run. And here you can see these memory addresses being the same, the multi-dereference output, and then also the value after a triple dereference output. So I think from a high level, I think that pretty much summarizes what a pointer is and kind of how you use them in C. In Python, we don't have pointers. Luckily, it's interpreted. There's a Python compiler that compiles everything to C for us. But in C, sometimes we are going to be working directly with the memory. And this is just how we do it, using either void pointers or traditional pointers and dereference. And that's going to wrap up our C versus Python mini lesson. And I know I kind of glossed over some details here and there, but my goal is to ultimately give you a straight shot in coding in a lower level language than Python, and I feel like the best way to do that was to show you in tandem with Python and C together. And I hope that it's going to be a valuable resource for you, and you can take your learnings elsewhere. So I'd like to thank you for getting to this point in the video. Please like, comment, and subscribe, and I'll catch you in the next one. See ya.